Unit 7C, probability, the OR rule, also called the addition rule. Two events are mutually exclusive means that they are separate. They're disjoint. They have no outcomes in common. They do not overlap. They cannot occur at the same time. Here's an example. The game is pick a student randomly. Are these events mutually exclusive? Sophomore and senior. If we had all the students at a school, we could divide those into freshmen, sophomore, juniors, and seniors. Could a person be a sophomore and a senior at the same time? No. These are mutually exclusive events. They would be separate from each other, disjoint. They have no students in common. Part B, junior and male. If we had all the students in the school together, the juniors might be in this circle, and the males might be here. Well, they do overlap. There is a possibility that a person could be a male and also in junior year. These two events, junior and male, would not be mutually exclusive. The addition rule, or the OR rule, has two forms. The general rule always works, and it says the probability of A or B is equal to the sum of the two probabilities, probability of A plus the probability of B, and then we have to subtract the probability of A and B. That rule always works. On the other hand, if A and B are mutually exclusive, then you could use this short version of the above rule where you don't need this last piece, and the probability of A or B is just the sum of the two probabilities, probability A and probability of B. Example, pick one object from the bag. Find the probability that you pick a red or a blue. Don't forget, or means one or the other or both. It's the inclusive or. We could do this by logic or counting. There are 5 possible outcomes for this game because there are 5 objects in the bag. We can look at each object and see if it's red or blue. Is this object red or blue? Yes, it's blue. Is this object red or blue? Yes, it's blue. Is this red or blue? Yes, it's red. Is this red or blue? Yes, it's red. Is this red or blue? Yes, it's red. They're all red or blue. Therefore, the probability of picking red or blue is 1. It's a certainty. It has to happen. If you pick one object from the bag, it has to be red or blue. Let's do the same example using the formula. What's the probability of red or blue? Here are the red objects. These are the blue objects. Notice that these two sets are mutually exclusive. They have nothing in common, no object in common. So we could use the short version of the rule. The probability of red or blue is just the probability of red plus the probability of blue. The probability of red is, out of 5 objects, there are 3 red, so the probability of red is 3/5. The probability of picking blue from the bag would be, out of 5 objects, 2 are blue, 2/5. Add these together, we get 5/5 or 1, as we did before. Example, pick one object from the bag, find the probability that you pick a square or a blue object. Let's use counting. Is this object square or blue? Yes, it's blue. Is this object square or blue? Yes, it's both. Is this square or blue? Yes, it's square. Is this square or blue? Yes, it's square. Is this square or blue? No, it's neither. So there are 4 objects in the bag that are square or blue out of 5. So the probability of picking square or blue would be 4/5. Let's try the same problem, this time using the formula. Here are the blue objects, and here are the squares. Notice these 2 sets overlap. They have a common element, the blue square. They are not mutually exclusive. Therefore, we have to use the general formula to do this problem. The probability of square or blue is going to be the probability of square plus the probability of blue minus the probability of square and blue. The probability of square, how many squares do we have? We have 1, 2, 3 squares out of 5, plus the probability of blue, we have 2 blues out of 5, minus the probability of square and blue. Well, of the 5 objects, only 1 is square and blue, the blue square, so that's 1/5. 3 plus 2 is 5, minus 1 is 4/5. So the probability of picking square or blue is 4/5. This is a contingency table which shows the party affiliation of a group of people. We have 2 male Democrats, 14 female Democrats, 5 male Republicans, 16 female Republicans, 3 male independents, and 10 female independents. A good idea when you get this kind of table is to put another row and column in for totals. So if we add 2 and 14, we have 16 Democrats. If we add the Republicans, we have 21 Republicans. We add the independents, we have 13 independents. And if we add the males, we have 2, 5, and 3. That's 10 males. 14, 16, and 10 would be 40 females. If we add the totals in the last column, we get 50 people. Or if we add a cross in the bottom row, we also get 50 as the grand total for the number of people represented by this contingency table. Now, if we pick one person from the group, find the probability that that person is male. Well, there are 50 possible equally likely outcomes. Of those 50, how many would be male? Well, that would be the 2, the 5, and the 3, which we said would be 10 males out of 50. You could reduce that to 1/5. What's the probability of picking a Democrat? Well, out of 50 people, how many would be Democrats? The Democrats are here and here. 2 and 14 make 16, so 16 out of 50, which reduces to 8/25. And finally, what's the probability of picking a male given a Democrat is picked? Well, here you start with the given. Given, you're only talking about Democrats. You're only talking about these people. You're only talking about 16 people. So we're choosing from 16 people. And what's the probability of picking a male? Well, of those 16, only 2 are male. So this would be 2 out of 16, or 1/8. What is the probability that you pick a non-Democrat? What's the probability of not Democrat? We could use counting here and just count the people that are not Democrats. Well, these people are Democrats. These people are Democrats. These are not Democrats. Republicans are not Democrats. Independents are not Democrats. Independents are not Democrats. So we could add these numbers together. Well, these two make 21, and these two make 13. 21 plus 13 is 34. So the probability is going to be 34 out of 50, or 17/25. We could do the same problem using the formula. The probability of Democrat is, we have 16 Democrats out of 50 people. Using the not formula, the probability of not Democrat is 1 minus the probability of Democrat, or 1 minus this number, 16 out of 50. Well, that's 50/50ths minus 16/50ths gives 34/50ths, or 17 out of 25. What's the probability of picking a male and a Democrat? Well, we could use counting and see how many people are males and Democrats. Male and Democrat means you have to be both. Well, these two people are male and Democrats because they're both. These two people are in the male row and the Democrat column. These 14 people are not male and Democrat because they're female. These are not male and Democrat because they're Republican. Not male and Democrat because they're Republican. The 3 independents are not male and Democrat, and the other 10 independents are not male and Democrat, so therefore there's only 2 people out of 50 that are male and Democrat. That can be reduced to 1 out of 25. Let's use the formula to do the same problem. Here are the males, and here are the Democrats. So the probability of male and Democrat is the probability of males. The and rule is the times rule, multiplication, times the probability of Democrats given male. Well, the probability of picking a male would be, out of 50, there are how many males? There are 10 males out of 50. Now we start with the given. Given, we're only talking about males. So given, we're talking about males. So We're only talking about these people. So how many are there? There are 10 of those. And of those 10, how many are Democrat? 2 out of 10. Well, we have cancellation here. The 10s cancel. And we get 2 out of 50, or 1/25. The probability of male or Democrat using counting. Don't forget, we're using the inclusive or, which means one or the other or both. Are these people male or Democrat? Yes, they are, because they are both. Are these people male or Democrat? Yes, because they're Democrat. Are these people male or Democrat? Yes, because they're male. Are these 16 male or Democrat? No, they're neither. Are these 3 male or Democrat? Yes, they're male. Are these 10 male or Democrat? No, they're neither. So how many do we have? We have 2, 5, and 3, which makes 10, plus 14 for 24. So we have 24 out of 50 would be male or Democrat, and that reduces to 12/25. We could also do this problem using the formula. We have males and we have Democrats. These two groups overlap. They have 2 people in common, so they are not mutually exclusive. We have to use the general or rule, which says the probability of male or Democrat is the probability of male plus the probability of Democrat minus the probability of male and Democrat. The probability of male, there are 50 people in the group. How many are male? 10. 10 out of 50. What is the probability of picking a Democrat? Well, there are 16 Democrats out of 50, minus the probability of male and Democrat. Well, these 2 people are male and Democrat. 2 out of 50. If we add those together, 10 and 16 is 26, minus 2, 24 out of 50, or 12/25. That's the end of Unit 7C.